Dr. Purushottam sir to talk about community bioenergy storage opportunities and benefits. So, introduction about Dr. Purushottam sir. He is having more than 30 years experience. I think he has started his career in HIT, and myself also started in career in HIT. Both worked together, and then I did ME at with the help of Gate score at CEG. He is completed his PhD program in the year. He is completed mechanical engineer, I think, mechanic from CEG, ME also from CEG, PhD from also CEG under the guidance of Dr. G. Nagarajan sir. And then he is working at the various administration level as a principal, as a dean academic. Now he is looking after controller examination in the college level. He became autonomous of our college, St. Peter College. This year we have got autonomous. Now he is taken charge as a controller examination as well as professor.
Myself and Dr. CHINNAPANDIAN sir were associating last 32 years. We are met in the HIT only, in the we are starting with the teaching career only. So thank you very much. And I am going to share some of the insights about the bioenergy storage and opportunity and benefits. Thank you. Because already we last 5 days we are gone through the solar energy, wind energy, hydrogen fuels, fuel cells, and storage, batteries, and energy auditing, and everything. So everything is a renewable energy only. So all the renewable energies already we are discussed and recovered and stored, and what is the application we discussed. So this is another the renewable energy is called the bioenergy, or is extracted from biofuels. So it is also one of the key sources of energy we can use for our societies. So actually this is what is the concept of community energy. So the community energy is about the people and the communities taking democratic control over their energy future by understanding and generating, using, owning, and saving energy in their communities, as well as the working together across regions, nationally and globally. So that is the democratic control over their energy futures. Because if you're going to use any bioenergy, so we need not get any consent from the government or anything. Because I'm from village, now also our village people are using the the wood to cook the rice or anything, and also the major bioenergy wood using for firing the bricks. So that is called the sule. So now they are using for a lot of the wood they are firing and converting in as energy and firing the bricks. So that is also the societal the energy of bioenergies. So the bioenergy is the energy derived from biomass, which are plant, animal-based materials taken from renewable sources. For example, dung, grasses, and wood product were early biofuels that people use in produce energies. So include the agricultural residues like crop, salts, and straw. That is the paddy husk. The forestry residues like wood chips, dust, and dedicated energy crops, and such grass and algae, the animal manure, municipal solid waste, and even algae. That is the pachai pasai. Everything is under biomass only. So the another municipal solid waste is very the problem we are facing to dispose the municipal solid. There is a garbage in the markets, vegetable markets. That also this everything waste only. But we are going to convert waste into energy is the technology we want to develop. And another definition for biomass and bioenergy can be produced from various vegetable through process, anaerobic digestion to create biogas, using a gasifier, by converting vegetable oils into biodiesel with the common vegetable source including sugar cane, potatoes, carrot and vegetables, crops like rapeseed and soya bean, utilizing either the whole vegetable and its waste product like salts, leaves and peels as feedstocks. That means all the fields, mean the orange fields also one of the biomass. That is my research that we are going to discuss later on. Another the definition for biomass is a renewable energy sources derived from any carbonaceous waste, because any carbon is there is the energy only. Carbonaceous waste is derived from numerous sources which include byproduct from the timber industry, agricultural crops, raw materials from the forest and also from household wastes. In the developed world, the application of biomass as an important source for combined heat and power generation is significantly increasing significantly. The combined heat and power is called cogenerations that using in sugar industries that we are little bit I am going to discuss. India accounts for one third of the total biomass consumption in the world. The biomass is used to fuel as a 90% of rural households and about 15% of urban households. Still, our people are using the biomass as a energies. In India, the primary biomass sources of production are agricultural residues like rice, husk, sugar bagasse, and crop stubble, with a current estimated total biomass available of around 750 million metric tons per year as per our Indian status. So with a surplus of approximately 238 million metric ton that can be utilized for energy productions out of 750 MTT. So the demand for biomass is driven by its use as a primary energy sources for cooking and heating, with a growing interest in utilizing the biomass for power generation through government initiatives promoting renewable energy sources like biomass power plants. So so far we are discussing about the wood conversions and bagasse conversions actually, but as per my research concern, so when you're doing my research, coursework, I didn't find any topic in this case. When after attending the courses, coursework, we used to go to the CEG canteen where they're using the sweet orange juice everybody is having and wasting all the peel up sweet oranges. So when I discussed with Dr. Miller and Dr. Murugan sir and Dr. Lakshmanan and along with our guide also Dr. Nagarajans, and he asked me to can go ahead, you can proceed whatever data is there. But after finding been searching the data, so we didn't get any data, only the orange oil using for only the perfumes and making the small oils to using the making candies, orange chocolate செய்யறதுக்கு பண்ணிருக்காங்க. Okay, this only using the very limited applications only. After searching the data, so we can get some what is the availability of or production of orange fruits. So in this case around 140 countries was over 662. This is the latest data. When I was discussed, only the 200 million tons only is there. Now they are produced, there are a lot of fruits we are cultivating all over the world. Okay, the orange skin, which is the bio waste, because it won't affecting the atmosphere or landfill everything. So because it's a biomass, we can use as a energy converter media as available in large quantity from the fruit shops, restaurant and hotels. It can be used for biomass derived fuel, which can also solve the problem and of its disposals, because the conversion of biomass into energy is very is a challenges for us, for researchers. So and the orange oil can be extracted from the peel of orange. The main ingredient of orange is D-limonene. So that is equivalent to diesel or petroleum product C10H16. That is this is the only data we have taken after discussing with our guide, and we can so because it's having some energy, we can take it, we can use for our internal combustion engines. So with help of this D11 only, because of the carbon is there, hydrogen charge is nothing but the hydrocarbon fuels. So as per the India concern, 48.80, 82 million tons per annum. They are recovering 0.6 percentage recovery of oil from the fruits by cold press process. That means 29.3 million metric ton of oils we are getting from 48.82 million tons. That means 0.6%, very less only, but we want to convert something, because you cannot just like you can throw, because disposing the waste is very challenges for us also. For that we can recover the oil, we can use for in any process. Okay, at present the production of orange oil is very limited to meet the needs for the food and soft drinks, perfumes, chemicals industries, hence the cost is very high. However, the price of orange oil can be brought down in the future by increasing the cultivation of oranges. Actually, there is a fuel extraction technique they can use. The D-lemonen is the whatever the oil getting from the orange is called the D-lemonen is the name. So cold press, pyrolysis, and steam distillations. So after finalizing the title, see, we started to collect the orange peel from fruit shops. So I'm staying in Porur. There are 3-4 fruit shops. I agree. I mean, just understanding with the I collecting every day evening. So 10 kg, 20 kgs like that. We have collected all the orange peels. These orange peels will be collected and will be cut into 4 pieces, and we are dried in our home, or I think with help of my wife, who has helped us for preparing these fuels. So actually, this orange the oil, the orange peel will be dried and make it as a powder, and the powder can use as a blended with the diesel. That means coal water slurry used in engines before Second World War. So with this technique, we have tried in our engine, but we can't achieve this after getting running with the engine with to 20 minutes or 30 minutes, will be the plunger, the injector will be failed. So in this case, we are that powder will be choked with the diesel for 20 days, 30 days, like that we are analyzed, and then the slurry will be filtered, that oil can use in the engine. That is another technique to recover the in the solid fuel into diesels. The diesel and orange peel powder will be choked in the different proportionate 10%, 20%, 30%, like that we can choke after some days. 15 days, 20 days, that all we are did in analysis. So we filter the all the slurries and take that oil, we can analyze the physical properties and then tested. That is the one technique we are used. Another technique we are trying in the lab models. This orange peel will be that is a dried one. This is the wet orange peel will be packed in the reactors we can use in the pyrolysis setup. That the main component of the main is a reactor, and then heater and condenser. So this is our the experimental setup when I did in the PhD. This is our lab in the old college, that means St. Peter's College of Engineering, St. Peter's Engineering College. We with help of our students, we have fabricated this, and reactor is there. In the reactor will be heated up to different temperatures. That means different quantity of fuel will be filled and heated with the different temperatures, and then this the fumes will be, the vapors will be passing through the condenser. The condenser will be condensed, it will collecting the oils, and then it is a water cooled condenser we used here, and because we want to cool the fumes in the form of vapor into liquid. Sometimes liquid will be condensed in the oil, and sometimes non-condensable gas also will going. During pyrolysis, you cannot condense all the gases into liquids. Maybe that is called you cannot condense. That means uncontrolled. It will goes as a vapor or gas. In the power plant also it will goes like that only. So these are the oil we are recovered for one batches, around 20 ml. 30 ml will get from the 1 kg of peel. Okay, the peel also fully dried, partially dried, and wet. Different parameters, different stage we are tried in the same experimental. We are tried. If you get partially dried, you get this oil in the center jar, and okay, in the right side jar. Okay, it will be the dried one or high temperature. It will be cracked, oil will be cracked, it will be forming, it will be losing their properties. So, and after getting the residues, this is after getting the oil, the finally we are taken the residues. This is a partially dried orange peel we are getting like that. If we that means if it is in the normal temperature or optimum temperatures. If you go for high temperatures, it will be burned. I mean, it not burned, but the oil will be cracked. After that, it will be getting this the residuals. But actually, what happened? No, when I did in PhD, during the PhD, during that, but the biotechnology, one of the faculty, he came to our laboratory. He collected all the residues here, and then there did another research in this the waste from the pyrolysis. So they are using for some other medical purpose, and also he got degree from this one. So because already we recovered the waste to weight as a oil, from the waste residual you can use for any manure for any plants. But he collected and he analyzed some medical purpose you can use. So it's another information I want to share with you. So the another technique is called the steam distillations. So the previously only the dry or wet or partially dried orange peel only packed and in the reactor will be heated up and will be collected the oil. But the steam distillation nothing but the orange peel, because the fumes will not formed in this when you dry it. When you take this wet orange peel and with along with water, and then it will be heated up. You will get some oils as well as water vapors. So same technique are used. These are the flow diagrams. The left one, the furnace chamber, and biomass will be packed along with the orange peel as well as the water, and passing to, I mean, after heated up, I think there are different temperature we are maintained. That data is given here, and then it will be forming a fumes along with the water vapor, because if it is 100 degree, obviously water will be forming a steam, and along with the fumes also will be mixed, and then it will be passing through the heat exchanger. So the previously we can use a condenser, it's a cylinder tube. Now we can use a pipe and pipe that slightly modified the condensers, and you can collected the liquid oils. These are the modified with the heat exchangers. That means only the through pipe and pipe heat exchanger we are used, because if you use more water, it will be condensation not proper occurs. For that we have changed that, modified during the PhD also, and we can use in the steam distillation process. So these are the setup I can use. Same reactor, but heat exchanger will be changed. So this is the left side diagram is actually this the schematic diagram. The right side will be the experimental setup. So there is a beaker, there is a salt water, and you can heat it up. The steam will be formed. That steam will be passing through the cooling condenser. You will be collecting again the water, okay, and separating the salt as well as distillated waters, and separating the salt separately. So this is the technique I use in my research also. So these are the oil were collected from the steam distillation. There is advantages over here. Oil will be will be less density. It will be floating up, and water will be high density. Will be because we can heat it again. We can remove the water also. That is another distillation process technique is there. But I collected and separated in water and oils. In this case, the water will be high density will be come down, and remaining oil is there. But there is you cannot get a proper quantity of this, because it will be mixed sometimes also. So in this case, you can go for another distillation. That's why in the orange oil is called the threefold oil and fivefold oil. That means you take this oil like a thick oil, you can steam, you can do the distillation, first distillation, second distillation, and fourth distillation, because high fivefold oil you can use for food product. Okay, and a threefold oil you can use for perfumes, body spray or anything. So but oil, in this oil we cannot distillate, we can use for engine only. Okay, so there are different trial we did here, trial 1 2 3 4 like that. So we are fixed the amount of peels 1.5 kg of orange peel with a dry condition, and the water taken as a 1 liter, and the initial furnace temperature maintained as 32 degree, and the temperature of cooling water also maintained at 15 degree. Initial temperature is 32 degrees in the furnace, and there is the furnace will be having the temperature controller, and we are maintaining first trial 300 degree, and then we are taken the oil, and then 400 degree, and then we are taken the oil 500 degree, and like that we are varying the different batches of feed into the reactor, and we are collecting the oils. And the last row, we can see that last row, there are oil extractor from here is in the steam distillation 150 ml we are taken, and second trial we are taken, sorry 120 ml we are taken, and then second trial is 180 degree, and then 140, and then 240 like that. So in the 240 will be the steam will be again, the water will be formed high temperatures, but 180 is the optimum condition we are taken in this case. And another trial we have taken is the orange peel quantity is maintaining at 1.5 kg only. We fixed the mass of orange peel, and the quantity of water will be changing it. So this the variable is 500 ml, 1000 ml, 1500 ml, and we have taken the same temperatures. So the previously the peel quantity will be maintained, and the temperature water will be maintained the same quantity, where I varied only temperature. Now I am varying the quantity of water added in the orange peels. So in this case also around you can get to 180 ml, but when you go for high, water content will get less quantity of orange oils. So another trial also we have taken, and I reduce the mass of I bearing the peel 1 kg, 2 kg, 2.5 kg like that we have taken, and added water quantity will be fixed, and the cutoff temperature also maintained. So when you go high quantity of peel will get more oils. So what we understand is, if adding more orange peel will get more oils. So around 260 ml we have taken. That is, it is the mixture of this oil and water vapor again. It will be separated again in the distillation process only. This is the trial we did during my research. So after that you will get this some residues. That is in the steam distillation process. So it depends upon the temperature, the residue will be get different qualities. So and also I tried for just we are grind the orange peel. Okay, in the help of the grinder we are grind the wet orange peel, and then we are, that also we are tried in the taking the oil from the the gasifier or pyrolysis. So like that there are several different temperature, depends upon the temperature you're getting the residues. So after getting the oil, we tested in the physical, because for our aim is to use in IC engines to replace the diesels. Okay, that's why I compare with the diesel fuels. The calorific value is little bit less, we can use more quantity. The obviously the fuel quantity will be consuming, and then the density of oil will be almost similar, and viscosity also slightly higher, and that's why you can blend it. But I tested in the 100% orange oil also in the engines. I started with the 10%, 20%, like that we can increase up to 100% also. The 100% oil research paper only published in the first one in the Science Direct in the renewable energies. And the CTA number also almost is very important in this case. The CTA number is the self ignition temperature, so we can use orange oil in the diesel because it's a 49 around 50 in diesel, orange oil getting 47. These are the physical parameters we are tested suitable for IC engines. And also we did ultimate analysis, what is the percentage of carbon content in diesel as well as orange oils, almost similar in diesel and orange oils. Okay, there is another advantage is there, oxygen content 3.25 percentage in this case. This orange oil is having the oxygenated fuel. The people are talking about if you use oxygenated fuel, okay, we can reduce the air consumption in IC engine. Obviously the self igniters, okay, or the enhancer, okay, the ignition and the oxygen using as a ignition enhancer, the combustion will be get properly. So these are the main advantages of orange oil in this case. Almost other properties are same, but it's having the oxygenated fuel because methane or ethanol will be the oxygenated fuel only. So it is combustion will be proper, will get more efficiency and reducing the efficiency. And okay, so almost okay, this is similarly the vegetable oils, any seed you can convert as a biodiesel. So far we are discussing about the biofuels. Now we can discuss that also, consider as a biodiesel when you discuss, I mean mix with the diesel. So I cannot use as a biodiesel, I can use only biofuel in my research because the converting bio waste into oils. But the already there are a lot of researches they done in the vegetable oils, that mean vegetable palm oil, soybean oil, rapeseed oil, sunflower oil, rubber seed oil, jatropha oil. There are a lot of research, a lot of paper is there. Almost all the I mean they completed. So another advantages here, this also is a non-edible oils. These non-edible oils converting oil is a raw oil, and then you can go for a transesterification process or esterification process to reduce the density of oil to equivalent to diesels. Then you can use directly or blended or any type of this one. So it's another technique is called converting the seed, I mean bio seed into biodiesel to you can use in the engines, or you can store any in the form of liquids. So maybe it's a main property of orange biodiesel is density, viscosity, heating value, CTA number, flash point. So almost nearly after converting the biodiesel, because the raw oil is called vegetable oil, after transesterified can do the chemical process, we can call it as a biodiesel equivalent to diesel properties. So that already there are so many researchers, they are completed the research in oils production of biodiesel is a big research, and then converting into energy in the internal combustion engines. So these are the different properties for orange, I mean in the biodiesels. So the same biodiesel oil I compare with the my orange oil also, because almost the heating value is very important. Okay, that is one. And then density you have to see, and then the another flash point and fire point. Almost the raw oil is having high flash point, and because after converting it will get reduce the flash point, because you cannot use the other biodiesel directly 100%. You can use blended one, but the orange oil you can use 100% directly without affecting any combustions, because less flash point and fire points and equivalent densities in diesels. So another technique I want to acknowledge our Dr. Murugan. He is in the third day we are carbon captures. Okay, carbon is capture in this ice engine. He is working in right now NIT Roorkela. He did this waste convert the waste tire into oils. So he did research in this. Whatever the tire wasting in, okay, after used tires, we can use with the pyrolysis technique. So because he's only helped, and he got the project in the Rajalakshmi when he was in Rajalakshmi Engineering College. He got project also. So I went to there and I worked along with him and conduct the experiment also. So just with help of our my friend, I sharing this because after that he did lot of experiment here. So take this waste tires, and then to remove the steel wires and bead, and then chipped okay, the small pieces, and washing to remove the impurities and the dust, and then removal of moisture from the tires. They are dried, and then you can use as a pyrolysis setup. The whatever I shown this experiment, he did in the big capacity, because the Ministry of Forest and Environment, he got project fund when he did in this project. So he did a big furnace, big condenser, and they are converting waste tire into oils. So these are the experimental setup we are used for getting these oils. The output oil is 5.5 liters from 10 kgs. If you take 10 kg of feedstock, he converted into 5.56 liters. So these are the you can see the oil very black, like a tar. So it's very high smelly, because when you're going to burn the tire, getting the smell. Similarly, the same smell is getting, and but converting finally, because if you burn openly, there are a lot of questions raised. You cannot burn the tire, because the burning tire is in the closed vessels, not in the open. If it is open, it will be very harmful to the atmosphere. But we are used in the closed container only. So we are getting the oil here. Uh, there are different the percentage of oil is you got it. So gas 6%, and the char, okay, the 52, oil will be 42%. That depends upon the outside reactor temperatures, so it's increasing, and optimum 500 degree we got 50%, 57% of oil. So like that, there is an analysis only we did it with different temperature. We got what is the maximum optimum oil we can extract it from this. So this is the oil comparison between diesel and tire pyrolysis oil. He named as a tire pyrolysis oil, and for my oil I can call orange peel oils. Like that, we did in the same experiment in Anna only. The same engine we run in the different oils. So he also analyzed the analysis for carbon content, hydrogen content, like that. And also he compared with the tire pyrolysis and the distillated tire pyrolysis, and compared with the diesel fuels. So the raw oil will be distillated and changing the property equivalent to diesels, because the tire pyrolysis is a very thick and high viscosity. So after distillation, you can get this one. So also is compared. So finally, all the fuels you can use in internal combustion engine. Either you can produce from the wood, you can use it. If it's the bagasse, you can use only the sugar industry to generate the power plant, because you can directly burn. Any conversion of biomass into oil, okay, you can get you can store any in the form of liquid compared to the gaseous fuel. The gaseous fuel, yesterday also we are discussing about the hydrogen, other gas. It's a lot of volume of containers required to store it. But whereas converting the gaseous fuel, biogas into gas into liquid, so you can store any in any place or anywhere in the compact high density storage. So but I don't want to discuss the experimental and the result and all. But I want to conclude as per my topic is, so I did. There are different phases. Cold water, now that is called the orange skin slurry, along with the diesel. We tested one experiment, and then raw oil we have tested directly, and then blended one, and then you can use diethyl ether as a ignition initiator. There are one more technique we did. There are 4 techniques we are completed. Along with this, we concluded during the research 30% of orange blended oil will be best performance, because we want to get high efficiency compared to the conventional diesel, as well as the less emissions. The CO, the carbon monoxide will be reduced because of already the oxygenated fuels, because 3 to 5% of oxygen content in the orange oil reduce the emissions. That is what we concluded in the my wife overseas. So obviously, under my guidance, another 2 the PhD candidate they completed in the alternate fuels and in the exhaust gas recirculations, and also one more candidate they did in acetylene as a gaseous fuel. The acetylene, my Dr. Lakshmanan, my friend, he also the the PhD members in our guide. So he also completed, and then another nano particles, that means bio nanoparticles used in the heat exchangers, the enhancers, that also completed. Under another candidate they did in composite materials in natural fiber. These are my research area, and still we are not involving, because last 5 years I'm in administration, so I'm not involving any research. Thank you very much. Patiently listened my presentations. So the produced bio oil from the any type of biomass is advantageous. Storage liquid oil is the most advantageous compared to the gaseous fuel. The biomass is the sustainable energy, that is important, because of compared to the solar, wind is a seasonal energy, but the biomass you can get anywhere, any place, anytime. So it will be the sustainable energy. You can farm as a liquid fuel to store, you can transport, you can carry anywhere, any purpose. Thank you very much, dear friends and professors, and listen me patiently. Thank you very much.
Sir,
Hello?
my name is Murthy. I am from Mother Vaishno Devi University.
Yes.
I attended your session, sir. This is a biofuel and storage. Very interesting, sir. As a research point of view, it is okay. So, what about this research? What do you call it? A business point of view or economic point of view? How it is going to be made this sustainable development goal number 7? So that my question, sir.
Yes, sir. Yes, sir. I think it's actually almost I asked our coordinator, Dr. Chinnapandyan, similarly. The cost effective still in the is slightly higher than the conventional fuels. So the same question. I mean, the cost effective is very very important. But for in the futures. In the futures, we want, but already the lot of the biomass plant we are using it, but the cost wise is higher, sir. Definitely. Okay, any form of biomass you can use. Because the processing cost will be higher, and the energy transfer cost also is highest in the form of in the power plant like that. But maybe 10 to 20% of cost is higher. Sustainability,
Okay.
as per the sustainability, that's why, sir, we can convert in the form of liquid oil, you can store. Okay, but because ever and ever now, okay, it's getting this biomass, but lot of people, because we are ready-madely is having the diesels. We know before 5 years we cannot afford to. I mean, it's very we cannot go for electrical vehicles. Now everybody they are using electrical vehicles, almost 10 to 20% of vehicles. Similarly, in the biomass or any renewable energy, you can use in the futures. In the vehicle also. Cost is high, sir, almost.
Okay, sir. Thank you, sir. Thank you, sir.
Okay, thank.
Any more
What are
questions?
they're asking? What are your thoughts on the commercialization of these technologies? Yeah, in the private, as per the private concern, we can start, we can produce the power, sir. Okay, we can collect the biomass, we can use it because almost the private power sector is there to because when using the natural gas, they're producing power and then they're connecting with the grid. Similarly, if you convert liquid fuel, you can use in internal combustion engine, or if you gasify the gas, you can use in the boiler to produce the electrical power. You can use. Okay, you can connect with the grids.
Photos, sir. Dear participants, please unmute your videos.
Almost all the fact. Okay, there's participants.